Quantum consciousness and the afterlife connection. Is there an afterlife? And can technology help facilitate a bridge between our realms? Instrumental transcommunication essentially merges quantum physics with everyday electronics to scientifically capture communications from the afterlife, attempting to prove that consciousness actually survives physical death. First, let's talk about quantum consciousness. Rather than a hard drive generating its own data, your brain may actually be an antenna tuning into a universal frequency. This theory says consciousness isn't created by the brain, but is a fundamental quantum field that connects absolutely everything. Emerging research challenges the materialist view of the mind as a mere biological engine. Instead of generating consciousness the way a bulb emits light, the brain may act as a receiver, tuning into a fundamental fabric of awareness like a radio capturing an unseen signal. Several scientific theories suggest human consciousness is a fundamental component of physical reality rather than a mere byproduct of biological processes. Renowned physicists like Sir Roger Penrose and John Wheeler argue that the universe requires conscious observers to transition from a state of probability into a tangible existence. Other experts, including Robert Lanza and Maria Strum, propose that space, time, and matter are actually projections or perceptions derived from a universal field of awareness. These perspectives shift the scientific focus from a purely material world to one where mind and matter are inextricably linked through quantum mechanics. There is a growing intellectual movement that utilizes mathematical modeling and quantum biology to bridge the gap between traditional science and spiritual concepts. Consider the stentor coeruleus, a tiny brainless single-celled protozoan. A Harvard study shows it learns and remembers. If an organism without a nervous system can learn, doesn't that suggest consciousness is primary? How does our physical biology link to this invisible field? Well, inside our cells, tiny hollow tubes called microtubules sustain actual quantum states. In addition, the protective coating around your nerves fires off entangled photons. Think of this entanglement as a lightning-fast biological internet that perfectly syncs millions of distant neurons to create your single, unified sense of self. How does the brain process all of this? The Blue Brain Project found that our neurons form tight-knit groups, or cliques. These cliques connect to enclosed cavities, building geometric structures that operate in up to 11 dimensions. Researchers describe it as your brain building and smashing 11-dimensional sandcastles as needed to process data, and possibly hide memories inside those complex high-dimensional shapes. Microtubules aren't the only quantum apparatus in our brains. The brain is actually a nested, multi-layered quantum system. Let's look at how these other mechanisms function as quantum processors. Proposed by theoretical physicist Matthew Fisher at UC Santa Barbara, Posner molecules are tiny spherical clusters of calcium and phosphorus floating in the fluid inside and between your brain cells. The nuclear spins of the phosphorus atoms inside a Posner molecule are incredibly well shielded by the outer calcium shell. Breakthrough studies in quantum biology have shown that the cylindrical, layered structure of myelin allows it to act as a highly sophisticated coaxial waveguide for biophotons. The brain appears to have an ultra-fast, light-based quantum communication network running through the myelin. Your DNA isn't just a passive blueprint, it is an active quantum engine. The two strands of the double helix are held together by hydrogen bonds, which are essentially shared protons. Protons within DNA regularly undergo quantum tunneling, meaning they can spontaneously pass through energy barriers to exist in multiple places at once. Far from being a chemical accident, your mind is an intricately wired quantum antenna built to experience the multidimensional fabric of the cosmos. Instrumental transcommunication tests this using electronics, specifically induction coils that create and detect electromagnetic fields to capture anomalous post-material communications, actual disembodied voices, transferring real information without any physical contact. The push to implement discriminative AI and source separation to achieve rigorous, non-generative signal processing is driving a quiet revolution in the instrumental transcommunication community. Leading experts like Dr. Gary Schwartz, Alexander McRae, and Tom and Lisa Butler, along with a growing network of independent coders, engineers, and tech-savvy researchers, prioritize building hardware and software that isolate authentic environmental anomalies without introducing artificial speech artifacts. These methodologies utilize advanced acoustic shielding, forensic audio analysis, and deep source separation to ensure captured signals are physically present rather than software-induced hallucinations. By focusing on mathematically sound filtering and strict binary detection, these teams aim to move the field toward mainstream scientific validation. Ultimately, the goal is to distinguish genuine post-material communication from random background noise through transparent, verifiable technological protocols. This non-generative approach is the only way ITC will ever achieve mainstream scientific validation. Just as standard tech evolved from giant secure mainframe computers to everyday smartphones, Afterlife communication aims to make that same leap. The vision is future homes having personal apps to text, talk, and video conference with the deceased. Ultimately, merging quantum field theory with rigorous technological testing could very soon transform afterlife communication from a paranormal mystery into an everyday household tool. If you found this video interesting, please don't forget to give it a like. Thanks for watching.